Morning, my students. Hope you are fine and good. Today we are going to solve problems 4, 5, and 12. So let's start. Exercise number 4 or problem 4. Find the angles in the following figure and prove that FH is parallel to MB. So we have to find the angles and then to prove that FH, this line, is parallel to MB. Okay, given from the coded properties here, we have that AM is equal to MB. Okay, from this code property, this means that this line AM is equal to MB. And angle AMB, this angle is equal to 90 degrees. So triangle AMB is right isosceles triangle. Okay, right, because we have 90 degrees, and isosceles because we have two equal lines. Okay, also in triangle AFH, we have AF is equal to HF from this code property. As you can see here, we have this line and here we have this line, this code property. So AF is equal to HF, and angle AFH, this angle, is equal to 90 degrees. So this triangle is a right isosceles triangle. So let's start with the angles. In this triangle AMB, because it's right isosceles and angle M is equal to 90 degrees, so these two angles this angle and this angle must be equal, because we have an isosceles triangle. So these two angles are equal, so each one of them must be equal to 45. How? Of course, we know that the sum of the angles in any triangle is equal to 180. Okay, minus 90. Why 90? Because angle M is equal to 90 degrees. So the final answer is 90. But we know that angle A is equal to angle B. So here we have to divide by 2. So A and B, angle A is equal to angle B, and each one of them is equal to 45 degrees. So in this way, we find angle A and angle B. Okay, so this angle is equal to 45 and this angle is equal to 45. Okay, we can check how 45 plus 45 plus 90, the sum of these three angles is equal to 180 degrees. Now in triangle AFH, okay, angle F is equal to 90 degrees and angle A must be equal to angle H. Why? Angles to the base of an isosceles triangle. This triangle is isosceles. Okay, so the angles to the base, this is the base, so the angles to the base must be equal. So FHA is equal to FAH, and both of them must be equal to 45. How? 180, the sum of the angles in any triangle, minus 90 gives 90. Okay, and this 90 we must divide it by 2 because angle H and angle A are equal. So this angle is equal to 45. Okay, and this angle is equal also to 45. Now we find the angles in the following, in this figure, in this two triangles. Now we have to prove that FH is parallel to MB. We have three ways to prove that two triangles are parallel. One of these three ways, we have to prove that these two lines, okay, FH and MB, are perpendicular to the same line. So it's easy. HF is perpendicular to FM. Okay, as you can see here, we have 90 degrees. So HF is perpendicular to this line, to FM. Also, MB, okay, it's perpendicular to FH. Here we have 90 degrees. So these two lines, FH and MB, are perpendicular to the same line, which is MF. So HF and MB are parallel.